Hello, welcome to LEMS, where we help you discover your passion for math. Today, we will be teaching you how to solve a transportation problem. I am Julibien Padel, and I will be your teacher for today. Solving a transportation problem requires two crucial steps: finding the initial feasible solution and using the stepping stone method to find the optimal solution or the best, least cost-consuming solution. In this video, we will be focusing on the initial feasible solution of a transportation problem. And to do that, we will be using the northwest corner rule. So let's go straight to the example. Lemes is a bookshop that has two warehouses and delivers to 3 customers: No, Law, and In. Each warehouse has 40 books and 50 books respectively, while No, Law, and In are in need of 30 books each. If Warehouse 1 can deliver to No, Law, and In for $8, $6, and $10 respectively, and Warehouse 2 can deliver to No, Law, and In for $9, $12, and $13 respectively, how could we optimally satisfy the demand of the consumers? Now let's put that in a table so we can best understand it. There. Now, as you can see, supply is equal to the demand, which is why we call this a balance problem. But we won't be needing that cell, so let's just remove it so it won't confuse us. Now, to start finding the initial feasible solution, choose the utmost left cell or the northwest corner of the transportation problem, then assign the maximum value allowable for each cell based on the supply and demand constraint. Northwest means upper left, so WH1 or the warehouse 1 for No. The maximum allowable is 30, so we put that in there and remove 30 from both the supply and the demand, which will leave us 10 for the supply of warehouse 1. Now exhaust or empty out each supply per row before moving on to the next northwest corner rule in need for assignment. So to exhaust warehouse 1, we simply give it to Law, which will give us 0 supply for warehouse 1 and 20 demand for Law. Since we don't have more supply to give to In on the first row, we move on to the next row. And to know if a cell needs assignment, we simply look at its demand. Since No already has 0 demand, we move to Law. And since he still needs 20, we assign it 20, which will leave us with 0 demand for Law and 30 supply for In. Now we move on to the next cell or the last cell that needs assignment: In. Since warehouse 2 still have 30 supply, we exhaust that and give it to In, which will leave us with 0 demand for In and 0 supply for warehouse 2. Now this will give us our initial feasible solution. We just have to multiply the assigned value and the transportation cost per cell. Then we add all of it. In short, the summation of assigned values times transport cost. This will give us an initial feasible solution of 930. Thus, the initial feasible solution is to transport 30 books from warehouse 1 to No, 30 books to Law, where 10 are from warehouse 1 and 20 are from warehouse 2, and 30 books from warehouse 2 to In, which will cost Lemes 930. However, this is only the first doable solution and not the most efficient. Thus, goodbye for now, and I'll see you on our next tutorial where we teach you how to look for the optimal solution using the stepping stone method. Bye-bye!